This is the Aftermarket Radio Network.
All right, welcome everyone to yet another episode of Diagnosing the Aftermarket A to Z. I'm Matt Fanslow, and I would like if everyone could welcome back one of my favorite guests, one of my good friends who has probably my biggest competition next to, Joe Rogan, of course, the Automotive Diagnostic Podcast. Sean Patrick Tipping, he is mobile diagnostic tech for ST, which probably means Sean Tipping, Mobile Diagnostics and Programming. He's also an instructor at Century College. And today we are going to get loaded on the air. Oh, wait, no, sorry. My note's wrong. Let me read. We're going to talk about circuit loading. The reason being, I do get some messages from time to time, and some of them with requests about topics to cover. And we've covered on other discussions, both on here and on yours, about circuit loading and testing, load testing circuits. And I think I had made a comment about almost being able to determine a technician's skill level with electricity based on their test drawer, and if it has a bunch of various sized lamps or lamp bulbs in it. So, they got a headlight, they got a, whatever, 194 or something like that. Thank you, Sean, for joining me.
Of course. Thank you for having me. As always, you're dropping that level of guest back down towards my level. So,
well, when you have Dutch Silverstein on, there's only one way to go. Down.
Well, and Paul Danner, Justin Morgan, so Liz Perkins. I'm bringing it all down, but I'm okay with that. We're gonna have fun. So,
I mean, Morgan didn't bring it up that much. Liz and Paul, yeah.
No, for real though, I've been enjoying the show, listening to it recently. It's been very enjoyable.
It's all about the guests. Didn't bring it up that much. Liz and Paul, yeah.
No, for real though, I've been enjoying the show, listening to it recently. It's been very enjoyable.
It's all about the guests.
Oh yeah, of course. I hear enough of you already, so.
Yeah, I think everybody's heard enough. That's what most of the messages say. Sean, you know how Napa supports your auto care center through national marketing? Napa will build upon the already successful Know How for All campaign and promote auto care offerings and services for do-it-for-me customer support through sales driver promotions, optimize targeted media and local markets and proven channels, give your repair facility an online presence on Napa Online, generating millions of views per month. If you are interested in partnering with Napa Auto Care and capitalizing on the Napa Know How for All national marketing campaign, contact your servicing Napa Auto Parts store.
Yeah, dude. So I don't know if it's like this cross country, but I know here around where I'm at, Twin Cities, Minnesota, I've always enjoyed going to Napa stores. So there's one local to me in Forest Lake. Shout out to Fred, Forest Lake, Napa. And that's exactly it. So it's an independent franchise as opposed to the like big corporate structure of like an AutoZone or O'Reilly's, which whatever, they do a fine job too, whatever. But the Napa store, the one that is close to where I grew up in Forest Lake, it's the same counter people that were there when I started out as a technician when I was like 19 years old. To this day, not everybody, but you recognize the same faces in there. And I mean, that's saying something for any business, but I can guarantee you that is not the O'Reilly's or the AutoZone in town. You'll see a new person in there every month that you go in there. And that makes a difference for me. Like, I'm going in there to get parts. Like, I know these guys, I know they're going to treat me right. I'm going to do the same for them. And that's just one thing about Napa, at least locally, that I've really appreciated is the franchise aspect of it. So
that's impressive. I mean, that's really impressive to have the same basic core working.
Exactly.
I mean, that's like, like you said, any small business, be it auto repair shop or just anything. You don't have to list them all off when you got the familiar faces, especially if they're good at their jobs.
Mm-hmm. Yeah, for sure. It was As the years went on, I was actually just routinely impressed by it. I'm like, how do you, especially in today's world, like how do you retain an employee for, coming up on a couple decades now? Like what is the magic sauce there?
I don't know. And I got to believe finding good counter people is rough.
Sure.
That have just enough automotive, car knowledge, repair knowledge, catalog knowledge, and also interacting with not just like the general public, but also shop owners or technicians or service advisors, all those personalities. And then, there's the product offerings now, I think, are so much larger than years and years ago, where they had certain lines, like all their brake parts were going to be by this vendor or this manufacturer, and that's not necessarily the case anymore. And they got so many degrees of products. That's impressive. That's really impressive.
Definitely.
So I got a message from somebody about elaborating more on electrical testing, specifically when it comes to circuit load testing circuits, and how to do it, how to know what size bulb or what to use to load with, when to load. And I just felt like that's a good topic. And I felt like, being the accomplished electrical tech you are, as well as the education background and having input from your experience teaching, I hate to say kids, like it's so easy to sit and go, you're teaching at a college. It's so easy to say, teaching the kids. And I gotta believe that a lot of your classroom is not kids anymore. It's people looking at a second career because the first one doesn't exist anymore or didn't pan out.
Yep. I have students that are older than me. I think every year that I've taught, maybe an exception on one, but otherwise I'll have at least one student that's older than me. And the first year I did that, it actually kind of took me back a little bit. I felt very strange about that, but they turn out to be the most respectful, best students you have. Of course, they've got a little bit more life experience and perspective and focus. And so I wish I had a whole classroom full of them, but yeah, it's a whole gambit of people. But I'll tell you what, that is definitely something that I've noticed. You don't always think about it. Again, once you've been through this for a while, if you're going to test a circuit, you just grab a tool because that is the tool that's the right tool to test that circuit, right? You know when to grab that 194 bulb, or you know when to grab the test light or the headlight bulb or the meter or whatever, because it's right for that application. But trying to teach a student what's the right application for this here, it's not necessarily such an easy thing to teach, right? Because there's so many different circuits on so many different cars. What do you use for this situation? I'll give you these 8 different ways to test a circuit. Well, which one do I use for this particular circuit on this particular car? That is very tough, because I don't think there's one concise answer for that.
In general, I can't think of too many cases where you're going to test open circuit, meaning you unplug something and you check for specifically like a power feed and a ground. There's maybe signals that, if they're putting some kind of a bias voltage, then you might be looking at that open circuit. That's fine. But the actual feed and ground for a load carrying device, you're really not going to ever want to test that open circuit.
No, that'll get you in trouble.
Yeah. And depending on the situation, it may not be prudent to just do the voltage drop. Like now you may want to substitute a load to verify the feeds. And, as an example, you're replacing a fuel pump. The fuel pump's bad, but we'll just say it doesn't work because maybe one of the brushes is just gone, evaporated. You can plug the fuel pump in and cycle the key all you want. It's not going to load anything because the fuel pump isn't spinning.
Right.
And yes, most likely if you put the fuel pump on, it will fix the car. But darn well, once in a while, you're going to bolt the fuel pump on. It will fix it for a few weeks or a couple months. And then it's getting towed back and it's got problems. So in that case, the first time you should have load tested that circuit. Fuel pumps. I suppose we could go specs and all that, but honestly, to figure out what to do, you could just pull up your wiring schematic, or I suppose if you really, I don't know, maybe, I don't want to say backyard, but maybe not quite as thorough as it should be. You could just look at the fuse block and the fuse ratings, like pull up, look at the fuse diagram on the fuse block if it's got one. If it's a Ford, forget about it. But you can look at it and say, oh, here's the fuel pump fuse.
Yep.
It's rated for whatever, 20 amps. Okay. I'm not saying you necessarily have to load the circuit for 20 amps, but you should probably at least load it for 10 amps.
Yep.
At least. And that's where you would, what would pull about 10 amps and headlamps. Maybe one, maybe two.
It's funny you bring that up about fuel pumps, because we're actually in the fuel system course of the program. Like right now, today, we were in the shop for that, and we're doing fuel pump amperage. And that's one of the things we go through is let's measure the amperage of the fuel pump. And one of the questions that I bring up and that comes up in the shop is, what's normal? And of course, that depends on a lot of different vehicles. And now we're introducing 3-phase too, which is a whole nother thing. But, just your traditional brush style DC motor, what's the normal amperage that we should see when we do this? And I talk about the waveforms and let's look for dropouts, but what's the right level of amperage? And again, that's the thing. We can get an idea by the fuse, but it's gonna vary vehicle to vehicle until you kind of build up some experience and some known goods in your memory banks or documentation. But looking at the circuit protection is definitely a good way to go. Do you have a rule of thumb, or do you go by anything on, like, if the fuse is rated for 20 amps, what normally is on the circuit? Is it half? Is it a third?
It varies, but I would say, and this is going to sound like a dodge. I'm sorry, not dodge vehicle, but dodging the question. That's actually a pretty good range, a third to a half. And I suppose it gets in a little bit to what's all on the circuit, because not every fuse is dedicated to just the fuel pump. It's probably more likely a fuel pump than other things, but once in a while, you're going to have one that fuse feeds like the entire fuel system. So the fuel injectors, the fuel pump. Okay, well, that fuse is probably rated a little bit higher than a dedicated fuse for just the fuel pump. So there, the third area is probably a pretty good range. But for an expected, if we're talking about expecting, if we're talking about just testing, I guess I kind of want to make sure it can pull, or that I can verify that circuit will pull at least half, if not even a little bit more. I'm not talking about trying to be super exact. I'm not trying to dial anything in and go, well, it flows 9 amps. It's rated for, it's on a 20 amp fuse, 20 amp fuse. I got to go grab some more stuff and start loading this down. It wouldn't hurt you to do it, but okay, what's the probability of this thing flows 9 amps, but it won't flow 12? Right. I mean, you got 12 amps, or I'm sorry, you got 9 amps. The headlight's really bright. If you wanted to, you could put your voltmeter on it and go, and it's still 12.5 volts, 13 volts. I got a maintainer on it. It's 14 volts. Chances are it's probably pretty good. I mean, when stuff goes bad, it goes.
Yep.
Case in point, we were going to record this a while ago and we put it off. I'm glad we did, because I had I had a vehicle in Monday, 1998 Dodge Ram 2500 with a Cummins. It's a sanding truck. So it has this hopper in the back that's full of sand and salt mixture. And they drive around, and it's just like, depending on where you live, what we're talking about, this hopper at the very back has this plate that spins and it throws the sand and salt around. Well, most of it throws behind it, but it throws it everywhere. Mm-hmm. And Minnesota, most of these vehicles were destroyed by oxidation. And this thing pretty much is destroyed. I'm waiting to hear or drive by it one day, and it's just, this big letter V where the frame has folded in half. That's what I'm waiting for. This thing is a rust bucket. And I don't want to say like it's a pile of crap or anything, but it's it is what it is. It's been eaten away by corrosion, rust.
Yeah.
And the complaint is has no exterior lights. None of the exterior lights work. And those that are versed with Dodge pickups in that age range, year range, I guess, and live in a environment that promotes oxidation probably already know what's wrong with this thing. It ends up there's a ground. So what happens is, you're going to start checking voltage at a headlight.
Mm-hmm.
Well, to get to them was kind of a pain. So I unplug it and the lights come on very dimly. Plug it in,
Sure.
They go out. Unplug one of the headlights and they come on. It's dim.
Mm-hmm.
And the only reason I notice is because my face is right close to the headlight. Otherwise, my shop area is pretty darn bright. You'd never see it.
Gotcha.
Turn the headlights off, or not turn the headlights off, turn the lights in the shop off, and it's just this eerie glow. It's not a long story, but it will flow some current. If I unplug the other headlight, the front lights come on, like the parking lights.
Uh-huh.
And it turns out they're not as bright as they should be, but they'd be bright enough to trick you into thinking they're working, right? I mean, you wouldn't know unless you voltage dropped them that they're really not where they need to be.
Mm-hmm.
But I don't think anybody during an inspection would go, oh, the parking lights don't work. So there's a ground underneath the battery. I don't want to say really on the frame rail, but it's on a pretty good heavy piece of the body where it bolts to the frame. And what happens is, and I understand we're in a podcast, audio only, but it's an eyelet with maybe a dozen wires.
Mm-hmm.
So you have a dozen ground wires going to this single eyelet. And the eyelet itself isn't really that corroded. And where it mounts to the body isn't really that corroded. But what's corroded is the wires that are exposed. The copper that's exposed from where that eyelet kind of has those, what would you want to call them, like fingers or whatever, that kind of clamp around the insulation.
Yep.
So from that point where the wires are exposed from the insulation are, quote unquote, bare to where they go to the crimp of the eyelet, that's heavily corroded and kind of broken away, but they kind of make a connection through one another. Mm-hmm. And it only acts up when it's loaded.
Sure. Yeah. There's only so many, depending on how you want to look at it, but so many electrons that can make it through that little doorway.
Yeah. I mean, for this discussion, that's perfectly perfect. Yeah. So fix the ground, make a new eyelet, and that fixes the front lights. The front lights work really good. The rear lights still didn't work. And the same thing, a really eerie glow. It turned out that when they installed the trailer hitch wiring, they used like one of those, might have been Hoppy T harness, like it tees into the brake lights. So you unplug the brake light line connectors, plug this in, and then you got at least the rear lights for the 7-pin that they laid the wires across, not the frame itself, but where there's kind of like this cross member. It's fairly sharp, and it just cut through. Maybe it shorted from time to time, and they just kept throwing fuses at it until it didn't need fuses anymore. And they're either driving around with the lights not working, or it oxidized enough to where it didn't matter. You could lay right on the metal and it didn't matter. But yeah, so a couple of instances where I'm verifying stuff with a headlight back there because I didn't have a ground. So I like those jumper wire reels. So
yes,
they're flat, they're magnetic. Yep, they got black and red wires with little alligators on them. I love those things. They're like
100%.
15, 20 feet long or something like that. Maybe longer. Maybe they're 30.
I say it's my poor man's power probe.
So yeah, I got one clip on the battery positive and one clip going to one side of my headlight, and then the other jumper wire from my headlight to the ground. And then I'm laying under the car looking for an issue. And when I find it, I can jump ground or whatever I need to do to see if my headlight comes on. And then, and also in this case, God, I don't mean to keep talking about this. Sorry. That the other thing with this is the rear lights ground through that eyelet underneath the battery that I just repaired. So
Okay.
I'm now still a little concerned that somehow, some way, as much as I cut the wires back, as much as I tried to clean them with a wire brush, as much as I tried to twist them perfectly and get them in that eyelet and crimp them, that maybe, just maybe, I have a bad connection on my repair. So I have to be able to prove that my repair can flow current from the back of the vehicle.
Sure.
And that's where the headlight comes in. Like, okay, if this thing will power up a headlight, my ground is good. My repair to my eyelet is good.
Mm-hmm.
Now I know the problem is between, so like I checked at the headlight, at the taillights, bad.
Mm-hmm.
Move up the harness. There was lucky me, a connector back there. It's like C310, back probe it. My light comes on. So I know from that connector back is where my problem is. And I know that my repair underneath the battery, my eyelet is good. It flows current that, whatever my headlight's flowing, 6-8 amps. So I know I'm good to go. That's important. That's really, really important. Did I need a headlight? Probably not. 3157 probably would have been enough.
But it proves it to you. That's visual representation that the current can flow. That's the best.
Yep.
Yeah, those frame rusted out issues are always interesting because I think a lot of technicians, myself included at times, don't really think of the frame as something that can lose a ground, but it can, or it can have a less than optimal ground. And that actually happened on one of my I had a 97 Chevy pickup truck. Actually, not that long ago, I had a 97 pickup truck. And that's what happened is the ground strap to the frame just fell away again because of salt and corrosion and stuff that's here in Minnesota. And so, one day the fuel pump doesn't work, and I did some tests and loaded some circuits and found, okay, I don't have a ground to the fuel pump. But not only that, because the fuel pump ground goes off the fuel pump and just has an eyelet on the back of the frame, back on the bed side of the truck. Yeah, it doesn't have a ground, but the frame didn't have a ground. And so I had to follow it all the way back to the strap. So I drove it down to school with some jumper cables going from the body of the alternator to the frame. And I was like, I wanted to see, I was like, okay, let's have the students look at this, because this is a really good one for students to go through to see, hey, can we work through this? I'm not going to tell them what it is. Like, let's just figure out why this truck doesn't start. Because I just pulled in the shop, took my jumper cables out, and then that was the project for a group in the shop. And it was a very difficult one for them because it's not intuitive that the frame of the vehicle of the truck could not be grounded. But it was such a good lesson. Like, here's the things that can happen, but here's how you check for it. When you were talking about with the connector and you proved it out, we can be strategic about it. And that's what I like about electric is like it plays by a set of rules that have to be. And as long as you understand those rules, you can win. That's the best part about it that I like about electrical.
Yeah. And I think it's one of those cases where, I probably could have videoed it and shown that with a corroded ground, if I'd have used my quote unquote computer safe test light, I could have been chasing my tail. Mm-hmm. Especially if I'm checking open circuit, or in this case, it was open circuit, but not because I made it open circuit. It's open circuit on its own.
Sure. And
through the corroded ground with my computer safe test light that only draws, maybe 200, 250 milliamps, a quarter amp. Mm-hmm. I mean, that's nothing. A severely corroded wire will flow a quarter amp or 250 milliamps, no problem. So that's why we want to stress these things out. Same with the voltmeter, right? It doesn't stress the circuit at all.
Yep. Can I tell you, I don't mean to interrupt, but...
No, please interrupt. I'm talking way too much.
I do a demonstration with my students when we're getting ready to go out to the shop for circuit testing. And so I take a jump pack I do it on a desk in front of the students. And I have a voltmeter and I connect the black cable or the clamp for the jump pack to the black lead of the voltmeter. And I hold the red lead of the voltmeter touching the metal in my left hand, and I touch the red clamp of the jump pack with my right hand. So I've got a voltmeter in one hand and a red clamp in the other, and I have the student read the voltage, and it reads 12 volts, right? At the tip of my finger through my body, and then we measure the resistance with the ohm meter too. And I'm like, am I going to flow any current? Obviously not, or not any usable current, but what's the meter going to show you? Is it's 12 volts potential through my body. We got to be aware of that if we're going to be using a meter in an open circuit. And I mean, we pretty much tell them at that point, like, you're very rarely going to do this. Maybe checking a 5-volt reference. That's when you can use it. But if it's an output that's doing some work, we're not doing this. And that's another thing that I try to stress upon my students is, what is the purpose of this circuit, right? Is it meant for a sensor? Is it meant for, a network? Is it just voltage? Is it data? Or is this for an output? Is this something that's doing work? Is it a headlight or a motor or a solenoid? We've got to treat it differently. We've got to test it differently. And then that's where the choice in tools comes into play. But you got to understand the purpose of the circuit before you can do that. Yep.
Yeah, it would have been the same with the ohm meter. Yes. The ohm meter would have showed a very good ground, low resistance, because it's not stressing that. It's not stressing it at all. It's putting out, I think the one meter I measured was like 4.5 volts. And, on a 12 volt circuit, 14 volt circuit, the impedance being so low, it's not loading that circuit. Not sure the impedance really matters in that case. It's just the amount of voltage it's putting on is extremely low compared to what, and then the current ability to provide current out of the 9-volt battery is going to be pretty low. So yeah, I thought that was a good example. I had another Chevy pickup, but quite a bit newer than the one you're talking about. Mm-hmm. The complaint was a misfire. It was not firing the coils on the passenger side.
Yeah, and left side of the block. I know where it is.
Yes, sir. Yes, sir. That's exactly. So there's a ground on the block, the engine block, kind of by the starter on the driver's side. And that fails kind of the same way, where it's not so much that the eyelet itself is corroded or the block is corroded. It's where the wires are exposed to get to the crimp, corrode away. And they don't necessarily corrode all the way wide open. They fail under load, because I drove this thing in. It didn't skip a beat. It ran great. So I let it sit there for a while watching, got my scan tool on there, and I'm tooling around. And then I kind of noticed some misfires popping up, specifically on cylinders 2 and 6. And you come to realize, like, you try to scope anything on the ignition on that side, nothing's happening. Mm-hmm. Yeah. And then you scope the ground. Well, what was kind of interesting is when a coil was not firing, not firing, when a coil wasn't charging, which isn't a lot, but the ground would be okay. And once it started pulling some current, the ground is gone.
Yep.
So it was kind of an interesting waveform, and really only happened when the engine RPM would slow way down from the misfires. That would get enough gap. I don't want to make it sound like it was a square wave, but it was sporadic. You could see where it looked like I had a ground, and then once it got loaded,
sure.
So that was interesting.
Have you dealt with? I'm sure you have, the generation newer than the one you're talking about. I'm thinking of maybe like 08 and up Chevy truck, where they had issues. I think it's even newer than that, like up to 14 and 15. I've seen a few of them where they had issues with the negative battery cable, like the whole cable assembly itself from the battery. And then it had a body ground, but down to the backside of the block, where there was some voltage drop issues with that. Have you had any luck with like real effective measurements and testing on catching those? Because honestly, I've replaced a few, but it was just off a service bulletin and it fixed the problem, and I was happy that it did. But I haven't had a whole lot of luck with testing on those to like really say, oh, there's the problem.
To go and say, oh, there is the problem. I guess the ones that I could pick out, and some of them, I don't want to make it sound like I just pick them out every freaking time. Sometimes I just do it out of general principle because I kind of know now. But the first one I ran into kicked my butt a little bit.
Same. Yeah.
It was intermittent. Anyways,
weird problems too.
Yeah. Yeah. Right. What ended up happening, and I think this fits. I think it fits what we're talking about. It's circuit loading, but it's different.
Mm-hmm.
And this involves using an inductive high amp current probe. What I did was I clamped it around the, in this case, whatever was the easiest one, I think might have been the battery positives easier to get to than the negative. And I got a big enough jaws to get around them all. But I just started hammering the starter over and over and over and over and over. And not so much like cranking it until it starts. I wanted to hit it so that the starter engages and starts to turn, and then I'd let off. And I over and over and over and over. And I started to notice that my current level started dropping, my stall current. So I guess what I'm talking about here is if you're using a lab scope with an inductive current probe, low or high amp, doesn't matter. We're looking at an electric motor, DC motor. If you were to take an ohm meter to that motor, it would measure extremely low resistance. It's almost like a dead short to ground. Pretty much a dead short to ground until it starts spinning and you get some counter electromotive force. So when you first engage that electric motor, you get a huge rush of current. So stall current will be called stall current. It'll be called inrush current, startup current. I think are kind of the main names. And a lot of times that will be like 2 to 3 times the fused rating of the circuit.
Sure.
So if we're looking at a fuel pump and we're cycling it on and off with a key or with some sort of a device, a switch, whatever, or we hit the fuel pump a few times to start it spinning, that if it's rated for, we'll just say it's fused for 20 amps, you'll see spikes 40 amps, no problem. Over and over and over and over and over and over. And it's so fast, the fuse doesn't care, right? Because fuses don't necessarily blow from the actual amps. It's the heat, right? So it needs some time, which I know that statement kind of sounds almost like an oxymoron, but it needs time to build up the heat to blow the fuse. Heat blows the fuse. Heat's created by the current flow. In this case, the current is not there long enough to pop the fuse. So a lazy test, you want to replace a fuel pump, or you're suspicious of a fuel pump's got low pressure and you want to verify power feed and grounds. If you're lazy like me, you're not raising the vehicle up and checking for power feed and ground at the fuel pump connector. You're taking your low amp current probe and your lab scope and you're hitting the fuel pump over and over and over. Don't do it just once or twice. Do it like 20 times. 30 times, just bang, 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 bang. And you want to see that stall current being like, 30 amps, 40 amps, bang, bang, 40, 40, 40, 40, 40, 40.
Sure.
Every time. If that fuel pump circuit is flowing 40 amps, do you really think you have bad contacts in the fuel pump really? Do you really think there might be a bad ground to the frame rail? Probably not.
Exactly.
So same case with this cable. Starter pulls 600, 800, 1,000 amps on that initial inrush. Okay, one time momentary is not a good test. But if you do it over and over and over and over and over and over and over, and you start getting that thing hot, all of a sudden it's not, before I was hitting 800 every time. When I was towards the end of the test, my wrist was getting tired. I was more like 200. All right. And then I knew, I had an issue with current flow. And in this case, I think on this vehicle, the complaint was slow crank times intermittently. Okay. Just, roar, 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 roar. And I think you would walk away from it, come back, and then would start up. But it was wildly intermittent. And the first thing you do is a starter. It's like, I don't know what to do. It starts every time. Yep. And after that, and then he's like, and then it was weeks later. He's like, I don't know if you guys got it, or maybe I got a bad starter. Like, yeah, I got a rough time with bad starter scenario. Can you drop it off and leave it? Yep. Okay. And so what am I going to do to test this? And you got the leads down on the starter and all that. And that would work too. But this we could just see it. It should hit high amps over and over and over. Doesn't. Mm-hmm. It did. And then it started not. Maybe crank it over for 30 seconds and then start doing the stall current test. It's like, it should hit 600-800 amps, 1,000, depending on your current probe.
Yep.
1,000 amps, whatever. It should hit it every time. Mm-hmm. And if it doesn't, you got problems. And now, granted, it's not sitting there like it doesn't hit 1,000 amps. Oh, bad cable. You just know it can't flow current. So I got bad connections, something, right? Or a battery is not capable of delivering.
Yeah, right. That's also totally possible.
But it sets you on the path, and that's what I got out of it. I got put on the path, and then, it was that cable specifically. And I think not on the vehicle when I had it off, that, I decided that had to be the culprit. I think I put it in like a vise and I just cranked on it and just green stuff started pouring out of where the crimps to the battery terminal.
Sure. Yeah. I've had a few of those, weird like communication, random issues, and GM's got a bunch of service bulletins on them now. That's a great way to look at it, is to really stress that circuit. I mean, that's what we're talking about, right? We're talking about loading these circuits, stressing them out, making them do what they were designed, or maybe even a little bit beyond, to see what's the status of this conductor. Here's an interesting question, and I mean, maybe I have the answer to it, but I'll ask it anyways. So the heat that's developed in a conductor, like a cable or a wire or a fuse, what is the heat actually from? Like, I mean, we say, it's the current flowing through it, but what's actually making the heat to pop a fuse or to make a cable hot that's going to a starter, or, something that has more resistance than it should? What's that coming from?
I think I'm going to go with the safe answer is essentially friction. I think that's what I'm going to go with, because
kinetic energy from friction.
Yeah. I think that is probably the best way to think about it. That, the wires have resistance, and because they have resistance, they oppose current flow, and you get a voltage drop. It becomes a load. Mm-hmm. Right. So we usually don't talk about wires as a load, but they kind of are a load. They're just a very, very, very minor portion of it normally.
Yeah, or at least they should be a very minor portion.
Some cases, depending on, maybe conductor selection or, entropy, they become a load. And therefore, because of that, they're going to do some kind of work. And the work is heat. Yeah, that's what we're going with.
Okay. I like
Until somebody writes me and says, hey, you're an idiot. You just did this one podcast about it. But yeah, I mean, it's doing work, and that's what it's going to do.
Sure. You had, I think when we talked about doing this, you talked about a term, ampacity.
Well, I am not going to take credit for that, because before we had talked, I was talking to Jim Wilson of Standard Motor Products, Jim Wilson of flatrater.com. He's a freaking genius. He's a genius in every sense of the term. Super nice guy. I think he'll be at Vision. So if you get a chance to rub elbows with him, I do it.
Okay.
Say hi to him, shake his hand. I mean, I guess I want to take a minute or two to just brag this guy up, because he was a GM flat rate tech, dealer tech. Mm-hmm. And he had a website called flatrater.com where every week he'd put up a case study, and he would start out like towards the beginning of the week would be the complaints and his initial testing. And then he'd kind of leave it up to the group, the members on a forum, to come up with either a test strategy, or using the data he provided, come up with a diagnosis. And then he'd follow it up towards the end of the week with, this is what it was. This is how I got to it. This is the data I was looking at. This is how I rejected this, rejected that. Well, it's all GM, but a lot of those techniques translate to almost everything. Mm-hmm. That is where I learned so much about just sitting for a few minutes in the driver's seat with the scan tool and looking at data and looking at pertinent data and just kind of thinking about how it works, I guess, if that makes sense. That's probably where I learned diagnosing restricted catalytic converters using fuel trims. And he explains his thought process, and it was just great. It changed my life. I have a reputation for scope stuff, and I love scopes, and will use a scope probably as long as I'm doing this for a living. I need the scope. I need to be able to see things a certain way so it works in my head. But he helped me not be so scope dependent that I could start looking at scan tool stuff and start thinking about things in terms of probabilities. Like what is the probability that this is a problem? I mean,
right.
It could be, but
probably not.
Really? So yeah. Anyways, we're talking on the phone, and I bring up that I wanted to do this podcast with you. He's like, "Oh, wow. You should talk about ampacity, or have you ever heard of ampacity?" I'm like, "What?" It's like ampacity. I'm pretty sure I've never heard of that. He's like, "Oh, it's super common." All the credit goes to him for this. And so, yeah, I had to dive in and see what the heck he was talking about. And yeah, in the electrician world, they use this a lot to choose the conductor for a given circuit, because they cannot they don't want to use too heavy of a conductor for save money, right? Because it's made out of copper.
Yep.
2, they definitely do not want to undersize this conductor either,
Yeah.
So if it's going to be a 20 amp circuit, they do not want to put a 14 gauge wire on that sucker, because the breaker will not blow in time. Okay. So you said you've done a lot of research in this. Maybe I'll kick it back to you, but yeah, definitely you should talk about ampacity, because
not a lot of research. I did some reading, and basically it's the amount of heat a conductor can, it's about the amount of current a conductor can carry on a regular basis without going above a certain temperature. So it's about the current, and it's about the temperature of the conductor, and it has to do with the type of metal for the conductor, the strands, the insulation, like that all plays a role, ambient temperature, which I was like, I was thinking about, I'm like, I wonder what they have to consider for a wire that's running along the side of a block that's, hundreds of degrees hotter than in the vehicle. Well, that has to play a role in the heat of the conductor and all that stuff. But yeah, it all has to do with the temperature and what it can safely do for what it's meant to do. Pretty interesting stuff, and a different way to look at the rating of a conductor. But it all goes down. I mean, you can simply put it as the size of the wire, right? And again, we were looking at a fuel pump with my students today, and we were scoping amperage for a fuel pump. That was the goal. And they came up to me, and they have the back seat up, and the fuel pump's right there. It's got 4 wires, and they're like, we can't find a diagram. And I helped them find a diagram, because that was, that's part of the learning process. But I was like, well, let's just look at this and see, we understand what we're after. We're after current. And so we can go after power or ground. So one of 2 wires, and there's 4 wires. Do you think we can pick out which one it is? Like, just logically, let's think about this. And I just sort of nudged them, and they figured it out. Like, okay, those 2 wires going to the level sensor, much smaller than the wires going to the fuel pump. Okay, what are these circuits for? What's the purpose? Why are they bigger? Carries more current, right? And so we see it all the time, but yeah, it's not always something you think of in the engineering of a vehicle, I guess.
Yeah, and I think you could, if you wanted to, you could leverage that a little bit if you wanted. That one of those situations where the fuse for the circuit is, 10 amps, but the wire where you're at that you're going to test is, 18 gauge, 20 gauge. Well, that portion may not flow 10 amps, right? Maybe it's like more of a parallel type circuit where that branch will only be flowing about 1 amp. And you can tell that by the conductor size. So instead of, it's got a 20 amp fuse, better go grab the headlight. I mean, it might do it temporarily, but I don't know if I would recommend that. That wire is going to start getting hot.
Yep.
You can look at that and say, well, geez, it's 22 gauge or 20 gauge or 18 gauge. Like, I could probably test that with 1 or 2 amps. And then I'll grab my, 194 bulb or my 3157. That was a question I was going to ask you was, what do you have in your drawer? What do you have in your test drawer?
Yeah. Well, so I do the mobile thing. So I have a bag, but close enough. And so I have 3 different test lights. One's about 150 milliamps. One's about 300 milliamps. And I only know that because I measured them. And then one, I stuck a bulb in there that's about an amp. And I found I use that very sparingly because it melts the plastic of the test light. If you just leave it on, it gets too hot. So I know the amperage of those, and then I have a headlight bulb. And for the majority of stuff, that takes care of the ranges that I need. And then you could add multiple headlight bulbs, but I guess I don't find myself needing that too often. Yeah, I don't run into a situation where I need that too often, but you could add, more.
Yeah.
Parallel.
That sounds very close to what I have. I do not have the really low impedance test light. Never bought one. I have the Harbor Freight one that, pulls like the 300-400 milliamps or so. Mm-hmm. It's a real bulb in there. And then I have the 194 bulb that I figure pulls roughly an amp. 3157 pulls roughly 2 amps. And I took the connector, right? So I bought the pigtail, if you will, that they go in and, powers up both filaments. And then I have 2 headlights, 2 seal beam headlights, like a 4156 and a 6054, I think.
Okay.
Just big seal beams.
Mm-hmm.
Once in a great while, I will have to put them. Now, we got to be careful how I word this. I will put them in series with a circuit, but they will be in parallel with themselves.
Sure.
If that makes sense. Yes. So that I get the current flow I'm looking for, but they're technically in series with the circuit. So
sure. Yep.
But that's if I really want to stress something out. And like you said, it's pretty rare. It's pretty rare. Are you a repair shop owner? Do you find yourself struggling with any of the following? Uncertainty about the future and competition. Are you spending too much time managing chaos and struggling with new employees? Do you lack time to invest in learning best practices, or there's no time to spend on effective marketing? How do your finances look? Are you reactive rather than proactive? Do you know where you should be, when to grow, when to shrink? If any of those situations describe where you are today, you are finally in the right place. Repair Shop of Tomorrow is Napa Auto Care's newest endorsed partner. They are helping shops all over the nation run more profitable automotive repair shops by utilizing proven business best practice marketing and coaching to leverage Napa programs to drive quality, car count, sales, and profits. Repair Shop of Tomorrow will look at productivity, efficiencies, effective labor rate, average hours per car, labor profit percentage, measure and manage labor, and how you can create net profit. Team up with coaches to create systems, operations, and procedures using a business flow chart to help you reach your goals. Repair Shop of Tomorrow will help measure and manage the results to help each business succeed. Best of all, it's not do it yourself. It's all done for you. Their goal is to help dealers do what they do best, fix cars and build relationships at the counter and in the community. Repair Shop of Tomorrow will take the other minutia off your plate. The Repair Shop of Tomorrow offers a tier-based program to not only generate more business today, but to transform your shop into a top-level shop of tomorrow. Repair Shop of Tomorrow can teach you how to make your shop profitable. They can teach you how to recruit and how to make more labor dollars for your shop. Interested in Repair Shop of Tomorrow? Call 440-545-1230 for a free 20-minute, no-obligation consultation or contact your servicing Napa Auto Parts store. We're talking about circuit loading. Another, I think, worthy of bringing up is kind of the opposite side of things a little bit, where you can use the current flow through a circuit to power a light to help you find an issue. So if you have a short to ground, something that's popping fuses.
Yep.
10 amp fuse, you could probably stick a headlight. You wouldn't really need to. You could put your 3157, 3156, whatever, bulb in that few amp range. You could stick that in there. And now it's nice and bright. And it's pulling current.
Mm-hmm.
And then using your wiring schematic, go around and try to, disconnect connectors or components or, wiggling harnesses. You'd probably save to the bitter end because that can get to be one of those things where it was broke.
Yeah. Now it's fixed.
I thought the issue is in this area. I don't think so anymore.
Yeah.
But
definitely fix some problems unintentionally before.
Yeah. And some people will put like little speakers or those alarms, so it whines while they're looking.
I bought a bag of buzzers, and the reason I did it was I had a short to ground on. It was a flatbed tow truck. It was so far away from the fuse box that I couldn't see my test light, like even if I wanted to. And so I bought these little buzzers. It was like a bag of them for, I don't know, $20 or something. And it was super loud, but you could hear it. And that was how I was finding the short to ground. But yeah, it depends on the situation that you're in, I guess.
Yeah, it works out really well. We probably would be remiss not to at least mention the Load Pro leads.
Mm-hmm.
I don't have them. I've never had them.
Yeah, I've never owned any myself.
I don't foresee getting them, although I do see the appeal.
I had actually just had somebody on the podcast that was talking about those leads, but I've never owned any myself. I've seen them used, and I get the idea, but my bulbs usually do the trick, I guess.
That's what I do. So if you're not familiar with the Load Pro leads, they plug into your meter or scope if you have bananas, jacks, or adapters. And what they do is they have a button on them, and you use them like any other test lead, but then you can hit the button and it loads down the circuit. I think it's around an amp, if I remember right. I could be wrong. Don't quote me on that. You're there with the meter already. You're doing the voltage drop testing. You want to kind of make sure it can flow some current. You can hit the button. It'll load it down. You're not looking at current. You're looking at voltage, and does it, the bottom fall out of it. I definitely see the appeal. Like Sean, I'm usually using light bulbs of some sort, of test light, jumper wires, and a probe of some sort, like an acupuncture probe, AES wave acupuncture probe. I'll back probe something, or if I'm going to pierce, I take care of it with liquid electrical tape. Yeah, I do pierce.
Yeah.
Live in Minnesota, and I pierce.
Yeah, it makes the most sense in a lot of situations. I have a question to maybe derail this, but it might kind of be along the same lines depending on the answer. Okay, so I
think the name of the podcast is Derailing the Aftermarket A to Z. No, it's Diagnosing. You're right.
All right. So it's kind of like that coil thing last time. It stems from the education world, and you start trying to teach this stuff, and then you ask more questions like, well, why? Okay, so and actually this is relevant to something I talked about just a little bit ago. So I said a fuel level sensor, right? How many wires does a typical fuel level sensor use in your experience?
I would say 2.
Yeah. So you got 2 wires. And what would that sensor be called?
Potentiometer? Is that what you mean?
Well, is it? Or
are you looking for, potentiometer or rheostat?
See, that's what I'm thinking is rheostat, right? Okay. And the name, I guess, could be debatable, and it doesn't really matter for my question.
Yeah, I think typically, potentiometer is used for very low current flow and their position sensors.
Yeah.
Or angle sensors, or maybe like speed of something. Not like rotating around, but sweeping. are more current flow control. So they're in control of
lighting or something like that.
Yeah, lighting, maybe, thermostatic for old style thermostat control for houses. And I think maybe in the old days with the old gauges, it was probably more of a rheostat. And now with the new sensors, it would be more of a potentiometer.
Okay.
And that's how I would dodge that.
Okay. And that's not even my question. The name could be debatable, and I would be fine to, give up on that. Fine. We'll call it a potentiometer with 2 wires, whatever. My question is, they do this very effectively. And I realize there are some applications where there's 3 wires, but I would say the majority going into a fuel tank to measure the level of something, right? Just a resistive track with a wiper is 2 wires. Why don't they do that with every other 3-wire potentiometer on the car, like a throttle or an accelerator pedal or an old EGR or anything that you're using a potentiometer that has 3 wires? Now you might say, well, what's the big deal? But what's a wire made of copper on 1 million vehicles? That's $1 million. Like, why use 3 when you could use 2? And I don't have a good answer for it, but I've thought about that as we're going through our fuel system course. I'm like, well, here's our fuel level sensor. It uses 2. It does the same thing as these other sensors we're talking about, but it does it with 2 wires. So why use that 3rd wire? I don't know.
I don't know where I would do the research, but I do find that to be an interesting question. It's like, I don't even want to answer because this is totally off the cuff. Like, there's zero preparation on this.
Yeah, I like to just spring stuff on you.
So I'm trying to think. Well, I'm trying to think of diagnostics, meaning a lot of those you can have coding for open and short and whatever. And I think you still code the 2-wire. That's interesting because
you do because they use it for the evap. That's why it's routed to the PCM in a lot of cases. And they're using it for a critical sensor for emission stuff, but they still use a 2-wire. Again, not in every single application, but most.
That is a very interesting question because I think.
What's the advantage over 3 over 2?
Well, I guess I'm just wondering about when it comes down to actual cost, and complexity.
Mm-hmm. And then, okay, you say the cost, like, let's say the cost isn't that big of a deal. Well, then why only use 2 in the tank? Is it something about safety? And that was my guess, is there something about, you're sending electrical, potential into an atmosphere with flammable substance, but that's obviously not a problem. No. We're running a DC brush motor in there. We're fine.
They spark like crazy.
Yeah. So that kind of was thrown out the window.
That is a really interesting question.
We noticed it going through the diagrams, in the engine course and then in the fuel course. I don't know.
Maybe we have to call it a rheostat and then bail. I mean, it's essentially doing the same thing, right? Because it's
exactly.
There's going to be a pull up or pull down resistor in the module, whatever that is. Probably the PCM if we're talking about fuel level, because of evap. Mm-hmm. So it's not like directly, going into sending this voltage into the circuit board. It's affecting a pull up or pull down that a comparator is across. Mm-hmm. I have to think about this. This is kind of interesting. What would be the difference?
There seems to be a pattern to it, but nothing that I can identify as why. Because you're right. It does the same thing. It does. Yeah. It does the exact same thing. But then why can't it why don't we use that to do throttle position or again, any other potentiometer? And I do realize for anybody listening that a lot of throttle position sensors now are Hall effects, but for years and years, potentiometers, and we still use them in places. So
I mean, I don't want to bail, but I kind of want to shelve it so I can research it. Or if somebody listening knows, can just email me.
Yeah, I bet you somebody listening knows.
I will not tell anybody that you emailed me. I won't give out any names. I won't mention you that you told me. And in a future podcast, I will tell Sean why. But no, seriously, if you do know, reach out. I'll give you all the credit. Yeah, I want to go find out.
All right.
I'm just going to hit the stop button. Yeah, I'm done. I'm out. Gotta go look into this now. Thanks for killing yet another night of sleep, you jerk. Why do I invite you on? Every time I invite you on, I just no sleep that night.
Here's more work.
Why do they do this on this coil? I don't know. And then 2 sleepless nights to find out.
Why? But why? Oh yeah. But yeah, that's what's fun about it. Learning this stuff and trying to figure it out.
So yeah, long story short, go to Napa. Hopefully they'll hear this podcast and have a sale on bulbs for technicians for testing purposes. Exactly.
Wire some of them up with alligator clips, and you'll sell a boatload of them.
Yeah, it's a necessary tools. They're right up there with everything else. I can remember it would be like technically the third shop I worked at that I had a vehicle in with oxygen sensor heater codes. I was under there with a headlight testing them, turning them on and off, the heaters on and off with the scan tool. And they're looking at me like I was nutso. I mean, they're right, I am, but I thought it was a good test. I verified that indeed everything was there needed to fire up them heaters. So the oxygen sensors on this occasion did fix the car. Yeah, and especially you hate to say just the Midwest, because I don't know who all uses salt, but that seems to be a big deal.
Oh yeah. Well, they say the Rust Belt for a reason.
Yeah. So it's a common practice for us to load test everything. If we go back in time, and this would predate me technically, but General Motors, if you were going to replace an engine control module, and this was back in the days of probably the late 80s, early 90s, where the test was open up the glove box, get a really, really long screwdriver or pry bar, and with the engine running, smack the engine control module a few times. And if the vehicle stuttered or stalled,
sure,
it needed a control module.
I think I remember that on the Chevy Luminas. That was the test. Yeah. Give it a really good smack and see if the engine stalled.
Yeah, and before you would replace it, you were instructed as a dealer tech, and then, in the Indy side, I kind of wanted to do my due diligence too, is you were to load test all those circuits with your, so you'd monitor the current, or in this case, using a bulb of whatever, load test it that way, but to verify those actuated circuits could flow current. And then, of course, depending on what it was, I guess we're talking about thermally protected drivers or transistors, if you will, quad drivers.
Sure.
An actuator, a shorted actuator would smoke the driver or the transistor. So you could plug in the new one and kill it. So you wanted to verify shorts. And that was definitely where you would be using your ammeter.
You can even take this understanding of what you're doing with a bulb or some sort of load to other sides or other problems that you're diagnosing. This was another one, again, with students who are trying to figure this stuff out for the first time. So we were talking about 5-volt reference, and let's say the 5-volt reference is shorted to ground, which happens from time to time. It's not an uncommon thing, whether it be a sensor or a wire or whatever. A 5-volt reference might get shorted to ground. How do you tell if a 5-volt, or how do you tell if any wire, for that matter, is shorted to ground, straight to ground? What's your check? How do you know? Do you take a meter and, there's 0 volts. Well, is that 0 volts or is that ground?
Yep,
right.
Yep.
And take your test light, power it up, and touch it to the wire. If it lights up, that is a direct short to ground, because again, you understand the rules of the game. And that has to be what's happening if that bulb lights up. And that's, I think, what it comes back to a lot of the time is just understanding these rules. If you can get them down, then you can apply it with your testing. And it's almost like cheating, I think, once you really understand this stuff.
But that's a really good thing you brought that up. because you can be scoping something. Just say something stupidly simple. Just a brake light switch, right? And when you hit the brakes, it drops down to 0 or close to 0. Probably 0. If you're really not paying attention, drops down to 0, but the brake lights aren't coming on. So in your situation, like what you said, that you have to do the next step. The scope wasn't enough. Now, I suppose you could put a current probe on and that would do the same, but you could just grab a light of some sort, test light, whatever, load that circuit. I do that all the time. I'm glad you brought that up because that's something I do all the time. Is 0 volts doesn't necessarily mean a good ground.
Right. Is it nothing or is it ground?
12 volts, depending on where it is and when it is, may not necessarily be good under load. I have to load test it. If I'm checking a power feed, but it's not getting pulled, like there's no load, well, I'm not proving anything. So my test doesn't mean squat. It means I have open circuit voltage there for sure. It's not completely open. Now I have to load it. Might be a test light or whatever, one of my various bulbs. I'm glad you brought that up because I do that all the time.
Well, another one that's interesting, this doesn't happen too often, but where your meter or your scope is actually enough of a load so a circuit that has extremely high resistance for whatever reason, and your scope or meter becomes a measurable load in the circuit. Yep. I remember one of the times I ran into that, I was so confused.
Was it a GM vent solenoid by chance?
I don't recall what it was, but I was like, it didn't make any sense to me because I didn't consider my measuring device as a load on the circuit. But I think it was like I'm setting this up poorly for anybody who's listening audio, but maybe you can explain it better. But I think I was getting like 3 volts and I was like, why? I don't understand. I don't get it. Yeah. Your measuring device is actually taking a very small amount of current out of that circuit as well. And if the resistance is high enough, now all of a sudden your measuring device is actually affecting the voltage in that circuit.
I've seen it on General Motors vent valves, specifically on cars like the ones where they're back on the driver's side rear wheel well. The first one, if you don't know about it, it's a mind job because you got your meter back there or your scope. In this case, it was a scope, and most scopes that I can think of offhand, their impedance is like 100 k ohm. Maybe a couple of them out there are maybe 1 mega ohm. Their impedance is 1 mega ohm. Some of them are less. I'm not sure I can think of one that's 10 mega ohm. I don't think Snap-on is. I should look, but generally they're like 1 mega ohm or less. So a lab scope and a digital storage oscilloscope will load a circuit slightly more than a voltmeter or digital multimeter. Those, for the most part, almost all of them are 10 mega ohms. And what that means is they don't load the circuit very much. But if you have a actuator like a vent valve that's failed high resistance, it's not open, it's high resistance, and it's 20 mega ohm. All of a sudden you back probe it and you got good power feed and you back probe the control side of it before you're actuating it, and it's reading 1 volt, 0 volts, or close to 0 volts, 3 volts in your case.
Yeah.
And then maybe you grab the scan tool and you command it on and it drops down to, a couple, 250 millivolt or, quote unquote 0 volts. And then you let off and it goes back up to like 3 volts. And you're like, what the heck is going on here? And you check your feed voltage again and it's, 12 volts or 13 volts, whatever. And it can be a bit of a mind job. What the heck, and when I did it, I had the scope. So then it's like, wow, my scope loading it down that much. And then I go grab a voltmeter and the voltage was different. It was high.
Sure. The
voltage was higher. So my scope was pulling it down pretty darn good. My voltmeter, not quite as much. And it's like, that's insane. And then if you measured it, OL.
Yep.
And it turns out it's the resistance was high enough, like you said, where now your meter is enough to create a path.
Yep.
To complete the circuit. And it's not enough to actuate anything. Nothing being actuated, but
right. It all comes back to understanding what you're doing with your test method, right? When I'm testing this, when I'm doing this with a test light or a bulb or an ohm meter or voltmeter, you got to know what you're doing with that test. Like, what are you actually doing to the circuit? What's actually happening when you're connecting this thing? And it is important to know, like, at least to understand when I connect this, what I am doing, and then let's measure it and see what's happening. But if you don't really understand what's happening when you put that test light on there, you're at a disadvantage. Like, it's so important to know.
On the flip side, very similar vehicle, setting vent valve codes, vent valve circuit codes. It may not be circuit codes. I think it might have actually just been a P0446 now that I think about it. But the part of it being a General Motors means nothing, but to be accurate is another General Motors. And I had one of my younger techs looking at it. And I said, well, you want to verify that it's working back there. So you go back there with the scan tool and turn it on and off. Do you hear the click? No. Okay. Are you ready to slam a vent valve at it? No, I better check power feed and ground. I'm like, oh, what are you going to use? It's like, oh, I've seen you do this stuff. I'm going to grab a light bulb. Attaboy. Goes and grabs a headlight. Okay. It doesn't turn the headlight on. So he's like, oh man, comes and gets me. And I'm looking at it like, yeah. Remarkably, you still have 12 volts power feed there. It just couldn't flow enough. Okay. You got way too much load on this circuit. For fun, let's see if we can find a specification on the resistance of this vent valve. And it's, 30 some ohms, I think. So that's going to be, roughly a half an amp. Roughly. So so we went from a headlight bulb to a 194 and it would light that up just fine. And I'm like, okay, so, you got to learn just why you wouldn't use this 194 bulb to check that fuel pump circuit. The flip side, you're not going to use the headlight bulb to check this vent valve circuit.
That's a great example. Yeah, knowing what tool to use for the job. I'm just thinking too here, the control modules now, we have to be aware, are also looking at that too. And if they don't like what you put in place, they'll just shut down the driver. They'll say, nope, that resistance ain't right. I don't like it. Too high or too low. And they'll just shut it down. I had a Volkswagen AC compressor where I was just putting a test light in place to see if it light up the test light. Nope, didn't like my test light. And the circuit code's the giveaway, but still, like, we got to be aware the modules are watching this stuff too. I had that on a Volkswagen relay coil even. It was really sensitive.
Yeah, I broke down and bought the special tool. If we're talking about the same compressors, I went and bought that 4 Seasons tester.
Okay.
If we're talking about the solenoid controlled one.
Yeah, it's in like
it doesn't have
GTI
a
or Golf or something. Yep.
Yeah, variable.
Exactly.
Yeah, I just went and bought the tester. So it tees into it. It measures the resistance. And then you have a choice. You can watch the module controlling it, and then you can take over control.
Oh, no kidding.
And drive it. And maybe they're less expensive now. It wasn't cheap when I got it, but darn it, we see enough Volkswagens and Audis, and not just them anymore. Like more and more are going to the variable. Do they call them variable displacement compressors?
Yeah, exactly. Well, clutchless. Yeah, they had the variable displacement with the clutches, but then
I know, right?
Clutchless. Yeah.
So I just broke down and bought it. 4 Seasons makes one. I think there's another one.
I didn't even know there was a tool. Let's check that out.
I'm sitting on a freaking computer. I could just as well look it up instead of. Oh wow, there's all kinds of them now. Ooh. So I have the 4 Seasons one. Robinair has one.
Oh, okay.
They do not look the same. The Robinair versus the 4 Seasons. I have the 4 Seasons one. It's been very good to me.
Okay.
Use it on more than just Volkswagen Audi. Like I said, you plug it in and like you don't run into that situation like you're talking about where they just shut it down.
Yeah. There's certain modules I think are more sensitive to that than others. Some mid 2000 Chrysler modules seem to be just overly sensitive to open circuits and shutting down drivers. And it's for testing purposes. It makes it just a bear to get through that stuff. Because if you don't have the proper resistance in place, the output state driver just shuts it down for you. And like, I just want to make sure the computer's good. Like, come on, help me out here a little bit.
Yeah, you wish there would be just more of that. More bidirectional controls, more ways to do bidirectional controls, key on engine off, key on engine running. Mm-hmm. Just make it easier to pull the trigger on a lot of this. Man, start another podcast just on this. Get me going about stuff they should let us do with their scan tools.
Yeah, exactly. Yeah. I want to be able to do anything I want.
Yeah, we need to trim some fuel out of it in this spot here.
Yeah, let me get into that fuel map.
I guess I have a scan tool that might do that.
HP tuners might get in there.
Well, sir, thank you very, very much for coming on again.
Thank you very much
for talking about this with me.
I enjoyed it as always, so thank you for having me.
All right. That's Sean Tipping, everyone. The Automotive Diagnostic Podcast, also a instructor at Century College, and also a mobile diagnostic technician, and a huge fan of hockey. It's true.
It is true.
Think I make it up?
A game on Sunday.
Your game, or?
Yeah. We're not doing so hot this year, but we'll keep trying.
Like most Minnesota sports teams.
On par with most Minnesota sports teams.
All right, man. Take care.
Yeah.
You've been listening to Matt Fanslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fanslow on social media and connect or on aftermarketradionetwork.com.